In this question, we have a person who throws a ball up with an initial velocity of 10 meters per second. The ball travels up until it reaches a maximum height, after which it drops back down until it hits the ground. Now, before we even jump into the question, I want to make it clear that this ball is moving with free fall motion. And I know this because the ball is moving up and down, and the only force acting on it is gravity. What this means is that the ball is accelerating due to gravity. And the acceleration due to gravity is always equal to negative 9.8 meters per second squared. Now this ball is moving up and it's moving down. You might be confused why the up part of the motion is free fall. But think about it. When that ball leaves the person's hand, no other forces except for gravity are acting on it. And so that ball is accelerating, it's slowing down due to gravity. And so both the up and the down motions are free fall. And so we can write that the acceleration on the way up is negative 9.8 meters per second squared, and if we needed it, the acceleration on the way down is negative 9.8 meters per second squared, because that's the acceleration due to gravity. And whenever you're doing free fall questions, the acceleration will always be the acceleration due to gravity. Now that we understand that this ball is moving with free fall motion, let's jump into the question. We are asked, how long does it take the ball to reach its maximum height? Let's start by writing down what was given. We just learned that the acceleration is equal to negative 9.8 meters per second squared, and we know the initial velocity was 10 meters per second. Now it may not be clear, but we also know the ball's velocity when it reaches its maximum height, and we will call this Vf. And Vf, the velocity of the ball at the maximum height, is equal to 0 meters per second. If you're confused by this, let's visualize it. So we have a person. This person has a ball. They throw the ball up, and that ball starts slowing down because gravity is pushing against it. At some point, it reaches a maximum height because it comes to a stop. It slows down so much that it stops, and it changes direction and starts moving down. Now what I just said is that the ball stops at the maximum height. And when an object stops, it's not moving, so its velocity is equal to 0. And that's why at the maximum height, the ball's velocity is 0 meters per second. Now what I want to do is use some vectors to make this motion even more clear. So imagine when the ball is going up, the velocity vector is pointed up, but the acceleration vector is pointed down. That's because gravity pushes down. If your velocity vector and acceleration vector are in the opposite direction, your object is slowing down. Now at the top, the velocity vector is equal to 0, but gravity doesn't go away, so the acceleration vector is still pointing down, and that's why your object changes direction. And then on the way down, your object is now moving down, so the velocity vector is pointed down, and the acceleration vector is pointed down, so now your velocity and acceleration vectors are in the same direction, so your object is speeding up. And so this explains why the velocity at the maximum height is equal to 0 meters per second. And I went into so much depth because in a lot of my physics tests, the professors like to ask, what is the velocity at the maximum height? What is the acceleration at the maximum height? And now you understand how velocity and acceleration work in free fall. Now back to the question. We are solving for delta t. How long does it take for the ball to reach its maximum height? Now I hope you can see that because we have A, VI, and VF, the best kinematic equation for us to use is our VF is equal to VI plus A delta t equation. Because all we have to do is rearrange for delta t, plug in our values, and solve. And what we find is that delta t is equal to about 1.02 seconds. So it takes about 1 second for the ball to reach its maximum height. Now we can move on to part B. Here we are asked, what is the ball's maximum height? So in this case, we're solving for YF, our final position. You can also think of it as we're solving for delta Y, because the change in position will be equal to the maximum height. Now what I want you to realize is we have a lot of variables. We have VI, VF, A, and delta T. So we can use any of these three kinematic equations. Now you might be wondering, what is the best kinematic equation to use? And now this is just my opinion, but we solved for delta T. And if you were doing a test, you might have made a mistake and your delta T might be wrong. And if you use a delta T that's incorrect in part B, then your part B answer will be incorrect as well. So the safest bet is to use the kinematic equation that does not include any variables that you had to solve for yourself. That may not always be possible, but we've got three options here, and I'm going to go with option 1 because it only includes variables that were given in the question, so I know those variables are correct. With that, I can use my VF squared equals VI squared plus 2A delta Y equation to rearrange for delta Y, plug in my values, and what I find is that the object's change in position is about 5.1 meters. And this change in position is equal to our ball's maximum height, and that's the answer to our question. This question was one example of how we can use the kinematic equations to answer free fall questions.